Me and my son were working on an Arduino board, and I could see the different resistors have different color band, but it's very difficult to identify it just seeing the images. So I thought it would be a cool project for us to work on to identify the resistor value just with a picture of a resistor. So let's see first what all are the different components we are going to use and try to do an end-to-end project. So the first thing is the data set. There were different resistors inside the Arduino kit. For simplicity, I have taken two data set, which is a 222 resistor as well as a 330. Let me show you some images first. So, so the data set is here, and these are the 222. Right, so these are, I took the images on different sizes and shapes and orientation, and the same thing I did with 330. So here are some of the samples, and by just looking I could see there are 5 bands and the colors are little different here, but I am color blind, so I cannot identify which colors these are, so that again makes it an even cooler project. So these are the 330 ones. So finally, once we have identified the data, the next thing we need to decide is the algorithm we are going to use for training. So these are deep learning algorithms, and we actually have two options. One is the convolutional neural network, and the second is transfer learning. So in case of convolutional neural network, we are building the different layers of the model ourselves. For example, here is a sample paper, and if you can see, we have different layers. So we have a convolutional layer 1, max pooling, another convolutional layer, so on, and finally your classification, right? And the convolutional neural network is a kind of, it's a type of neural network or deep learning network which uses a filter um, to do the feature identification. So it, if you can see here, right, it passes a filter through the layers, and with that it's able to identify what all are the details from that image. So that is the one example we are going to use. The second option is called transfer learning, in which you use an already pre-built machine learning model and change some of the layers of it to make it for your use case. And the data set you're going to use, or the model we're going to use, is from a TensorFlow called MobileNet. This was a model which was specifically built for mobile vision applications, and we are just going to change the final layer to suit our application. Now let's see how those two CNN based as well as transfer learning options work. So here is our notebook, and most of the things are common. We first load our data set. So the one thing I also want to highlight here is, without masking or changing the data, I could not make it work well. So I did some transformation on the data, or kind of remove the skin color of the resistor, right? So if you can see the resistors, I try to filter out the skin color, so that with this change it was able to identify the resistors better. So that's the first step. That's common for both if you are using CNN or the normal or the transfer learning option. So there are two data sets, one is 220 and 330, and we loaded both of them. Then I'm just printing some of the samples. We are splitting it into 70-30 for validation and training. Finally, here is where we are building our model. So there's a convolutional 2D layers and the max pooling layers, all of them combined together. Finally, we are saying, as it's a binary classification, our value is 1 and it's going to be a sigmoid, so it's going to predict 0 or 1. And we are using Adam as well as binary cause entropy for the loss, and the metrics while it is doing the training, what we are interested in is called accuracy. So this is how our model looks, and it has around 3 lakhs 69,000 trainable parameters. So it's kind of a big model, and it would be finally having around 14 MB. Finally, we say model.fit, which will run 30 epochs or 30 iterations, and we are getting around 97% accuracy. So that's how you build the CNN model, and here is where I have plotted the loss as well as the accuracy. So that's the way for CNN. And now if you want to do the same thing for a transfer learning problem, most of this looks the same, and the only difference is where you are creating your model. So first you're having a base model of MobileNet, right? On top of that model, this is our base model, you're adding few more layers, right? So the final layer, similarly here, it's a dense layer which is going to predict either 220 or 330. So it's a binary classification problem. Same step, we are compiling, you are fitting, and here also it runs different iteration. The accuracy was better with the transfer learning, I believe, because the model already knows how to identify images. So this one worked better in our case when we were trying to give a new sample. So that's the two ways you can build a machine learning model, either from scratch, a CNN network, or using transfer learning. Now another question which would come is whether to use a CPU or a GPU. Both of this works for our simple use case where the images are less, and on my machine I was using a CPU, and for trying it out I also tried it on Google Colabs where you can get a GPU. So the only difference was I was adding this device type as GPU, and we tried again 220 and 330. All of this remains the same. The biggest difference is the time taken for training. So when I tried with two options, one inside Colab itself, one with a CPU and a GPU, the GPU one was taking almost less than half of the time. So when you are training a bigger model, I believe the time would be even very less. That's why nowadays everybody goes for a GPU when you are training a deep neural network. I hope that gave you an idea on how you can use machine learning for an image classification problem. I will put all those details of this project in GitHub, and feel free to try out any of the use cases you have. Thank you.